Alright, hi guys. So in this video we're going to be continuing differential calculus that we started a couple of videos ago, and we're going to be tackling another rule and knowing when to apply it. It's known as the product rule. The product rule. And the reason it's called a product rule is because when you think of a product, you think of, for example, you think of multiplying it, like the result after multiplying two things. For example, if you have A times B, that's equal to AB. AB is the product of A times B. In this case, that's pretty much what's going to happen here in this video. So let's say we had the problem 4x, x squared plus 2x to the power of 3. So now at first glance, when we're trying to find dy over dx, which again is the notation for the derivatives, we actually would use chain rule because we have an exponent that is raising this entire expression to a power. However, we would also use the product rule because we have 4x as the coefficient. But you might be thinking, well, in the past video, wasn't there a question where we had 3 times and then we had something like x cubed plus 3x plus 2 raised to the power of 7? Didn't we have that? Well, in this case, we would only use the chain rule. Why is that? Because there's only one part that contains x, which is this part. However, when we look at this function here, we have two parts that contain x, the coefficient and the actual chain rule part. So when you multiply anything, when you multiply two values of x, when you multiply two things that contain x, so for example, if you're doing 4x 3x, we would also use product rule. That is, we would probably not use product rule only just because we could simplify this. But although we know this gives us 12x squared, like when we multiply it out and then we differentiate to get 24x, we would actually have to use product rule to simplify it with this. So if we were just leaving it as this form without multiplying it out, then product rule would also give us this answer here, except it's unnecessary and that's why we wouldn't use it. But let's start off by explaining what the product rule is. So product rule is another way of differentiating, and like I said before, it's when you're multiplying two values of x. In this case, this value and this value are being multiplied. So in this example, we're going to have to use both the product rule and chain rule because we also have an exponent that's raised to. But first, what's the product rule? So if we have dy over dx, we could break this function into two parts. So the 4x we could represent as u, and x squared plus 2x to the power of 3 we could represent as v. And what we'd have to do is write dy over dx as duv over dx. Because essentially, y is written as u times v. This is u times v, which gives us uv. And then the way to express duv over dx is dv over dx times u plus du over dx times v. So essentially that means what we'll be doing is differentiating one part of the function and then leaving the other one untouched and multiplying them together and then adding it with the other part being differentiated and the other part being left untouched. So for example, in our old one where we had 4x times 3x, where we did not simplify it further and we used product rule to differentiate, we would first differentiate. Let's say 4x here is u and 3x here is v. So we would first have to differentiate v with dv over dx, as we can see here, which would give us, so 3x is actually just 3 when differentiated, so it's just 3. Then you multiply it by u, which is untouched, which is 4x in this case. It would be helpful as well on the side to write 4 equals du over dx and 3 equals dv over dx. That saves you time from having to keep differentiating on your own when you can just plug these things into the formula. And then you add it to, and then the differential of the du over dx in this case is 3. Sorry, du over dx is 4 in this case. And it's multiplied by v, which is 3x. When we simplify that down, it gives us 12x plus 12x, which is equal to 24x. And if I recall, that was exactly what we got in the previous, like in the previous way we did this problem, where we expanded it out. So I'll just confirm. So 4x times 3x is 12x squared. And the differential of that is, bring that down, 24x, which means that they're both equal, and therefore the rule is correct. And you can actually check that way to make sure you've done it properly. However, with problems like these, the ones I've just put above, this problem, it's actually very much, it's very difficult to simplify. I mean, of course you could expand the x squared plus 2x, but as we stated in the last video, with chain rule, it simplifies that entire process of having to expand the brackets. So what we're going to do is we're going to use product rule in this case. But before we do that, we have to use chain rule to simplify this part, and therefore get d. Well, since this is represented by v, we need to find dv over dx. So 4x equals u, du over dx is very easy to find. That would just be 4. With this, we're going to have to use chain rule. So let's say x squared plus 2x, since that's being raised to the power, let's call that a. So x squared plus 2x equals a. And now let's plug a back in there. So it's a cubed now. Now let's differentiate a to give 3a squared. I'm just doing it quickly. You can check, you can do it slowly if you want, pause the video, but I'm trying to make sure I get across the product rule itself. And then you actually differentiate the part inside. So it's 3a squared times, and then differentiating is pretty easy, 2x plus 2. Put that in brackets, which gives us 3a squared 2x plus 2, which gives us 3, and then we substitute our value of a back in, x squared plus 2x, 2x plus 2, and we can further simplify that we can further expand the brackets if we want, to give 6x plus 6, x squared plus 2x. Okay, so this here that I'm just boxing right now is our value of dv over dx, because we use chain rule in this case. If you haven't watched the video on chain rule, I would recommend you do so, because otherwise this will look very confusing. All right, so now let's do dy over dx as a whole. So remember, dy over dx can be represented as duv over dx. And our equation is dv over dx multiplied by u plus du over dx multiplied by v. All right, so now let's actually substitute our values in. We've got, let me make sure I write this as dv over dx. Okay, we've got all our values now. This is u, v, du over dx, and dv over dx. Okay, I'm going to take away the circling because it makes things look untidy. Okay, so dv over dx, that's just 6x plus 6 multiplied by x squared plus 2x, and then that's multiplied by u, which is just 4x. And then we add that to du over dx times v. So du over dx is just 4. Right on the next line here, and we multiply by v. V is x squared plus 2x to the power of 3. And oh, sorry, just before I continue, I forgot to raise this to the second power. You guys might have caught that out, and my apologies for not adding that. So we actually have to add the power of 2 over there. And now it's correct. This part is now correct. We can simplify that further by multiplying this by this part, which gives us 24x squared plus 24x multiplied by x squared plus 2x, and then that's added to 4 times x squared plus 2x. If we're really picky, what we could do is even, let me just add the powers, what we could do is even just factorize the x squared plus 2x. Since they're multiplied by each term twice at least. What I'm saying is we just factorize x squared plus 2x squared, because they're in both terms. And then that's multiplied by 24x squared plus 24x plus 4x squared plus 2x. Let me just make more room. And that can be simplified further, as we can see, because this here is a lot of simplifying to do. So it become x squared plus 2x, don't forget the exponents like I did, times 24x squared plus 24x plus, and then we expand the brackets, 4x squared. Oops, let me just write that again. 4x squared plus 8x. Oops. Okay, and then we can finish simplifying. And that's multiplied by, so 24x squared plus 4x squared is 28x squared. 24x plus 8x is 32x. And there you have it. That's our simplified expression. We probably could factorize some things from the 28x squared plus 32x. What I mean by that is 28 and 32 are both divisible by 4. So we could actually write it as 4 times x squared plus 2x to the power of 2 times 7x squared plus 8x. But either way, it doesn't matter. They're both correct. So this would be our answer. Okay, let's do a couple more problems, 1 or 2 more only. Alright guys, so for the sake of time, I'm just going to do one more problem, and then I'll give some worksheets in the description so that you can practice. So, find the derivative using the product rule, and y is given as 1 over x plus 1 over x squared times 2x cubed minus 1. So they're not always going to tell you to use the derivatives, find the derivative using the product rule. But if they do, then we can first just write down the equation. So the equation for the product rule is wait, I'm going to write a bit lower than that. duv over dx. And remember, uv represents y because this is u and this is v. v. And then there it's basically just u times v. And also, we can recognize that this is the product rule because we're multiplying two values of x. They're both being multiplied. But in the end, we're going to differentiate it. And unless we were going to simplify this until it's just unique little, like unique powers of x just added up together, we would have to use the product rule. Otherwise, we could use the power rule, but that would be very painstaking, which is why we can use the product rule. All right, so duv over dx is equal to, then dv over dx multiplied by u plus du over dx multiplied by v. So that's essentially how it works. We've identified our values of u, which is u is 1 over x plus 1 over x squared, v is 2x cubed minus 1. So we may as well just go write them down. 1 over x plus 1 over x squared, v equals 2x cubed minus 1. What's great about this question is that we don't have to use the chain rule as well. We can really just use the product rule. The power rule we always will use because, for example, when we have our final, when we have dv over dx and we've got to evaluate that. So for example, in this thing, we're going to have to differentiate it using power rule. The product rule is just the overlying thing. The power rule is always going to be there. Just note that. We can also write down du over dx. To make it easier, we don't have to keep searching when we're doing the problem. So the way I would first do this is, before even I write du over dx, I would actually write u in terms of powers of x solely. So I do not like having x in the denominator. It makes things very complicated to work with. So 1 over x I can express as x to the power of negative 1, obviously. And 1 over x squared is x to the power of negative 2. That's much easier to work with. So that's why we can say that du over dx, and then we use power rule now. So bring the negative 1 down in this term. So that'll be negative x, and then decrease the power by 1. So negative 2 plus, and then do the same thing with this next part, which is actually not going to give a plus. It's going to give a minus. Minus 2x to the power of negative 3. Yeah. And now what we can do is do the same thing for v. Let me just drag it all the way here. dv over dx is equal to, so this one's a much easier one to work with, so it's essentially just 6x squared. Now what we can do is we can substitute all these values into the product rule. So duv over dx is equal to, and then dv over dx is 6x squared, as we've seen. That's multiplied by u, which is 1 over x plus 1 over x squared. And then this is added to du over dx. So we can actually just convert our du over dx, which is right now in negative indices, back to the normal thing. So we would write this as negative 1 over x squared. and then minus 2 over x cubed. Put them back in its fractional form. And that's multiplied by v, which is 2x cubed minus 1. So we can simplify this further to give 6x, because I'm just multiplying it by each value in here, and the x cancels out. 6x plus 6, and then it's added, to I have to change that, negative 2x cubed plus 1 over x squared minus 4x cubed plus 2 over x cubed. And then we can simplify that more. To be honest, the actual differentiation isn't that bad. It's more about the simplification, which is quite annoying. And here I would just take the same base. So I'd change everything to x cubed plus, so negative 2x cubed times x is negative 2x to the power 4. Then x times 1 is just x. Now this is with the denominator of x cubed minus 4x cubed plus 2 over x cubed. Simplify further, get 6x plus 6. And then we'll simplify it internally, and then we'll only bring it out when it's all simplified. Negative 6, oops, sorry, not negative 6. Negative 2x to the power 4 minus 4x cubed plus x plus 2 divided by x cubed. And therefore, we can convert this to the base, with the denominator of x cubed. So 6x times x cubed is 6x to the power 4. And 6 times x cubed is 6x cubed. And now we can include the other parts. That's all divided by x cubed. Which gives us, so 6x to the power 4 minus 2x to the power 4 is 4x to the power 4. 6x cubed minus 4x cubed is 2x cubed. I'm just collecting like terms now. And then plus x plus 2 divided by x cubed, which is our final answer. Oh, sorry, one more thing. Before I end the video, I just wanted to say that with regards to this problem, leaving it like this, which was just when we plugged it into the product rule, is also perfectly fine because it's just like a factored form. The answer that we got at the end was the very much simplified version. And you don't need to go through all that algebra. In fact, it may be actually beneficial to just remain with the factored form, as examiners like that better. But I was just showing the simplification. But anyway, thanks for watching this video and see you in the next one.